And welcome back. Today we take up Chapter 1. We talk about application development. We talk about object-oriented scripting. And I have a couple illustrations here. On the right, I have my skill saw, my trusty skill saw that I can use to put together walls. I can use to build sawhorses. And on the left, I have a custom miter box that when you need to cut a really precise angle. The idea is the right tool for the job. Okay, what's so good about scripting languages? Okay, that's what the text tells you. My scripting languages for me used to be my skill saw. It's the one that I went to, I knew how it worked, and for most cases it did pretty well. You know, it's got that little laser light and it's got that tilt and all that. It's got some built-in stuff that makes it easy to use. And scripting languages come with some data structure that helps things along. Okay, and it says, why are we talking about uh-oh? Well, I scripted without uh-oh, object-oriented language, or object-oriented objects. Scripting without uh-oh was no fun. You spend a lot of time calling something procedurally when it's a lot easier to go object.method or object.attribute. Now, the other thing about most languages today, if they're not object-oriented themselves, they have it running under the hood. I run across a little bit of object-oriented programming even in SQL. Okay, interpreted versus compiled. I remember when I first started out programming just after punch cards, we had this thing called Fortran 4. And Fortran 4, you typed in your command, it ran it, and it either worked or it didn't. Then they had this thing called Fortran 77. I didn't understand all the commands back then, but the neat thing about it is if I mistyped something, it would tell me. And back then you had to have share time on a mainframe, so if you used up all your allocation, you had to go begging to the administrator to get you some more time. Okay, Perl and Python are somewhere in between. It seems to be a trend these days, is everything's kind of levitating toward the middle. And they talk about bytecode, which is then interpreted like a VM, and I looked at it and I said, oh, that sounds like Java used to be. I guess it still is. Okay, systems programming language is supposed to be closer to the machine. It's supposed to, each command is only a few commands of machine code. Scripting languages is supposed to be a very high language level. The other thing about scripting languages is easier to tie applications together with them. For example, if we decided for some reason at Charleston Southern we wanted to keep track of how long students were studying in the library or various places, we can have badge scanners scattered all over the place. Well, the problem with that is badge scanners need to be constantly awake. Kiosk type application need to constantly be awake. Windows wants to go to sleep. So what you can do then is you can take your executable and then you wrap it in a script that keeps that executable in the forefront, make sure it doesn't get distracted by things like the screensaver or security patches or other types of distractions. System programming languages are strongly typed in general. That drives me crazy because I started back when everything wasn't strongly typed. You found out you had the wrong type when you ran it and it gave you weird results. So I kind of like scripting languages, coming up with computers and all that. Another thing in scripting languages is everything is outputs are assumed to be character strings. You don't have the problem where you try to output something and you try to stick it together with something and it says no, you can't do that. That's an integer 32. Okay, scripting check, you find out problems when you're running and it breaks on you. That's good and bad. Now, runtime performance for type checking is supposed to be slow you down. It's supposed to be a penalty. Maybe with modern processors, that's not a big deal. I don't know. Okay, mentioned before, scripting languages operate at a higher level of abstraction. Every command you give translates into more machine code. Okay, page 6, it tells you that you got a 5-to-1 average, as opposed to 101 machine instructions per code. supposed to be more productive with scripting languages. I found that that may be true with the general run-of-the-mill when you use them to take care of the chores. If you're trying to do something really fancy, you probably need a systems language. Okay, another thing is your scripting languages has nice things like hash tables all built in so that you can use them instead of having to build your own. One thing you can do in scripting languages, one thing they discourage doing in SQL as an aside, is to process a string as a snippet of code. You say run this as code. System languages won't let you do that. It's a little risky from a security standpoint. In the SQL world, that's how we got SQL injection. Okay, function overloading. If you want to have 5 different versions of equals, you can do that in system language. You can't do that in scripting language. That's not what they're for. Okay, scripting languages. When I worked in Visual Basic, VB Script, I got to the point where I was thinking in terms of it. I could just sit there and I could just write code. A little bit harder for systems languages. Okay, and this brings us to everybody's favorite slide.